This is a TV program about Galileo, and it's called Galileo's Battle for the Heavens. It's an important bit here which I'm showing you about the relativity of motion. So we get into it now.
Galileo was born into a world where each morning reaffirmed the common view that the sun moved around the earth. This belief was confirmed as the sun appeared to pass overhead each day. It was a view of the universe originally set out by the ancient philosopher Aristotle. In the center sat the static earth, the home of man. The sun was just one of many heavenly bodies which circled endlessly around it. Dissenting from this accepted worldview could prove hazardous. A statue of Father Giordano Bruno marks the site in Rome where he was burned alive for a host of unorthodox beliefs.
I don't know. What a beautiful expression that is. So candid in its honesty. It's better than the occult explanations offered by certain philosophers. The number of people that can reason well is much smaller than those that can reason badly. If reasoning were like hauling rocks, then several reasoners might be better than one, but reasoning isn't like hauling rocks. It's amazing. A single gallon bar of steam easily outruns 100 wagons pulling horses.
If, like a galloping steed, the Earth is hurtling through space, why can't we feel the movement? Galileo seized on the paradox that the Earth could spin on its axis fast enough to cause day and night without people sensing the motion.
What is really exciting about Galileo, and you see it exactly the same in Einstein too, was the way he picked up what seemed to be an absolute impossibility. He said, we have this incredibly strong evidence that the Earth is not moving. Everything that our senses tell us is that the Earth is not moving. And yet, Copernicus has got these rather strong arguments from astronomy to suggest that the Earth is moving. So then Galileo says, well, this actually should tell us something very deep about how nature works.
So he devised an intriguing thought experiment. He used a horse to represent the motion of the Earth. If a rider dropped a ball while standing still, the ball would, of course, fall straight down, landing beside the horse. But what would happen if the same rider dropped the ball with the horse at full gallop? In Galileo's experiment, the forward motion of the horse would be communicated to the ball through the rider's hand. As the ball dropped, it would continue to move forward and would still land beside the horse, just as it had done when the horse stood still. To Galileo, when the horse and the ball shared the same motion, it was as if the motion did not exist. If the Earth were moving, could we be carried along with it and not be conscious of its motion?
There is a sort of a principle of relativity where if you're sort of moving with the Earth, everything shares the same motion. Not only is the Earth moving, but I'm sharing that motion as well. And therefore it is all hidden. It was probably the first really great thought experiment in physics. In fact, he was so confident of the result, he never even bothered to do the experiment to show it was right.
Despite his troubles with the church, Galileo was still well supported by the Medicis. He moved closer to his daughter, to a hillside villa outside of Florence.
Florence, that is
So there we have it about the relativity of motion, and when we get to Galileo, he deals with it correctly, I believe, and when we get to Einstein, he deals with that sort of situation and he totally messes it up. There you go. So that's what modern physics is about. It's the relativity of motion, and it's being totally messed up by Einstein.